students, and welcome again to my channel. My name is Mr. Meshak Ngige, and welcome to eMaths with Mr. Meshak Ngige. This is a channel that takes you through revision and also lessons on engineering mathematics topics and also in general mathematics. Kindly, if you have not subscribed, kindly subscribe, share, comment, and let us engage via the channel as I help you out in skills to do with mathematics. Now we continue with our series that we're doing in complex analysis revision questions from past papers, and we now check the March-April 2025 series. So the 2025 series, that is the March, just the other day. And the question asked, given that f of z is given by the function of exponent z plus 1, express fz in the form of u plus vj, then 2, show that u and v are harmonic functions. Are we together? Now, so solution. So our function f of z is given by exponent z plus 1. But remember, z is written as what? Z can be written as x plus y j. That is in terms of the Cartesian plane. All together. So in the Cartesian plane, we have our z being given by that. So therefore, if we rewrite this, we shall have exponent x plus yj then plus 1. Then as always, collect real terms and imaginary terms together, the real and imaginary. So this one again is the same as saying exponent. This one is a real value and a real value. So we have x plus 1, those ones are real. Then we have exponent, then we have y, then you have yj. Let me first of all, then we have yj. Then from the laws of indices, if you have the same base and you have added the powers, you can return this to the original state, which states that if you have am, so I can just state it here, that if you have am multiplied by an, the answer is always am plus n. And you can see our equation is in this form, which is in the second form. So we can return it back so that we can be able to express these ones in terms of trigonometric ratios, that is in polar form. The core thing we're doing here is to change the exponent form back to polar form of writing complex numbers. So we have, since we are adding, remember this one is a term on its own and this one is a term on its own. So we split them into two. So the first one will have x plus 1, okay, let me put it in bracket. Then the second one will have exponent yj. Now, so if you remember again from the video that we did previously, from the first question that we did previously, is that in polar form complex numbers are written in the form of r theta. Are we together? R, then we have theta. Okay, now when it goes to exponential form, all right, when it goes to exponential form, this one goes and it is written as r exponent theta j. All right, together. So this one is polar form, this one is exponential form. Now if you check this part and the whole of this equation, they look familiar, they look the same. All right, because this one is the exponent of theta j, and here we have exponent of yj. So in this case, it means our angle theta is represented by what? Is represented by y. And if you check, this part here is a real part because it does not have a j. So this part is a real part, and you can say that can as well represent the what? The r. Are we together? Now, the same way in polar form, the angle theta is just a short representation. Right, together? It is a short representation of this. So in full, this one is always written as r, then cos of theta plus j sine of theta. So the theta part, which is written now in short form, in full form, it is represented by that. We have checked that in the previous video, so kindly check it out, where we checked the expressing exponent of z in terms of real and imaginary. So we are saying The theta part is represented by that. The r just remains to be the r. So we are going to rewrite this part to be in this form. Okay, so our r will be this value because it is a real value. So we shall have exponent x plus 1 outside into bracket cosine of. Now our theta here will be represented by the what? By the y. I hope we are together. This angle now is represented by the theta here is represented by y. So we shall have y plus j sine y. And this is a representation from exponential form, and you change it to polar form. Then we can open this bracket into real and imaginary. So we shall have exponent x plus 1 cosine of y plus exponent x plus 1 sine of y. Then you can put that into bracket. Then you write what? We write j. And our first part has been solved because we have written our function fz in terms of u and vjy, because this one is our u part, this one is our v part. So u, v, then the j. So our first part has been solved. Now let's come to the second. We show that u and v are harmonic. So we have conditions to be met for functions to be harmonic. So since we have the u and v, so we have our u, which is given by exponent of x plus 1, then cosine of y. Then our v here will be represented by exponent x plus 1, then we have sine of y. So remember, for them to be harmonic, the two of them, remember we were checking for the two of them. So we are saying for the two of them, so it will be du squared with respect to x squared, again d squared u with respect to y squared. The answer should give you 0. Same here, d squared v dx squared plus d squared v dy squared. The answer also should give us 0. So basically we're just saying differentiate the function twice, then check. If you add the two, the answer gives you what? The answer gives you 0. And we shall go to that directly. So now let's check partial derivative of u with respect to x. If you check the previous video, and I'll advise you to check the previous video, what the derivative of x plus 1 became. X plus 1, we used, we call it function of a function. That is the chain rule, because remember, when you're just differentiating an exponent function, you drop the power altogether, you drop the constant that you always have. But this one is a function. So which value are you going to drop by the end of the day? So you can see this one is a function. So what you're saying is you can just use chain rule for you to solve. And we saw again that when you differentiate exponent of x plus 1, the answer remains exponent x plus 1. So remember, we are differentiating with respect to what? With respect to x. So if I differentiate with respect to x, it remains the same way. So I'll just have exponent x plus 1. Remember, cos of y is a constant. We treat it as a constant. So we don't interfere with the y. The second time, with respect to x, again, it is just x plus 1 cos, then y. Now let's go with respect to y, du dy. So with respect to y, so the function with respect to y, when you differentiate cos, you get negative sine. So you shall have e x plus 1, then sine of y, negative sine. So that is why we have a negative here. Differentiate the second time, we shall have, now when you differentiate sine, it gives you positive cos, so it doesn't change, it remains, it doesn't change the sign, because when you differentiate sine, it gives you cos. So the negative remains e x plus 1, then you have cosine of y. Therefore, we check if you add this and you add that, what does it give you? Exponent x plus 1 cos y minus exponent x plus 1 cos y. What does it give you? Exponent x plus 1 cosine of y. They're supposed to add but here we have a negative, so it changes to become a negative. So x plus 1, then cosine of y. So therefore the answer gives you what? 0. Therefore U part is harmonic, confirmed. Let's go to V part. So again, dv dx, we have said when you differentiate exponent x plus 1, it remains the same. So x plus 1, then sine y. Second time again, d squared v, then d with respect to x squared, it remains the same. X plus 1 sine y. Right, together, it doesn't change. Then we come to dv dy. We now differentiate with respect to y. Now we differentiate sine. When you differentiate sine, you get cos. So again, e x plus 1, that one is a constant. This one becomes what? Cosine of y. Then d squared v dy squared. Now differentiate this one the second time. So when you differentiate cos, you get negative sine. So negative x plus 1, then this one becomes sine of y. Now check the second derivative and the second derivative. This one is a positive, this one is a negative. So when you subtract, when you add the two, sine y plus then minus, so it becomes negative x plus 1 sine y, and when you add the two, therefore it is also 0. Therefore u and v are harmonic. As easy as that, and you get yourself some good 10 marks. So now we check the second part. This one had 5 marks in the series March-April 2025. So given that the f of z is given by the function cos x cos y plus j sin x sin y, show that the real and the imaginary part of fz satisfy the Cauchy-Riemann equation. So I'm sure we are so aware of that. So what are the two equations of Cauchy-Riemanns? That du dx should be the same as dv dy, that is the first one, and dv dx partially negative du dy. So we identify our u and we identify our what? Our v part, then differentiate it each once, then we compare the two. Now our u function is the real part without the j, so it is cos of x cos of y. Then our v part is the part with the j, so it is sine of x sine of y. So now let's differentiate with the x, differentiate with respect to y. So du dx. Now when you differentiate cosine function and sine functions, those are hyperbolic functions, they don't change negatives and positive, they just interchange. So a cos becomes a sine and a sine becomes a cos without interchanging of negative and positive. You can prove that from differentiation. It's just the same. You differentiate it using exponents, you'll see that indeed that one is true. So when you differentiate cos, it comes sine x, this one is a constant, becomes cos y, so you don't differentiate this part, only this. Then du with respect to y, again the function with respect to y. Now when you differentiate the part that has a y, it is a cos, and when you differentiate cos, it gives you negative sine, so it will give you negative cos of x, then this one changes to become what? Sine of y. So this negative is for the sine, so we just put it outside here. dv dx, again when you differentiate sine, it just gives you what? Cos x, sine y remains. Then dv dy. So you differentiate this part, okay? When you differentiate sine, it gives you cos, no change of sign. Are you together? Oh, sorry, we're not using this one, we're using this one. So we have now y. When you differentiate sine, it gives you what? It gives you cos. So it doesn't change negatives, so it just becomes sine of x cos of y. So now we just prove the two. So what is our du dx? It's given by that, sine of x cosine of y. What is our dv dy? Sine of x cos of y. Are they the same? Yes, so the first condition has been met. Let's come to the second. That dv dx, what is our dv dx? Cos x sine y should be the same as the negative of du dy. So negative cos x sine y. Now when you open the bracket, negative gives you what? It gives you a positive. So therefore if I open that, that gives me a positive, and I rub that. So therefore this one is cos x sine y, cos x sine y, and the two are the same. So you just say what? Hence analytic. So and that is as simple as that, and you have yourself some good 5 marks. So welcome again as we check our second example, and that again comes from the November December series 2024. Remember, we are checking a series of questions that ask about analytic functions, that is the Cauchy-Riemann's equations, or harmonic part of the function. So this is a question that shows that the function u in terms of x and y given by the function is harmonic. That is one. Then 2, determine the conjugate harmonic function v such that the function itself, the whole of it, becomes analytic. Now, solution. So the first part is to show that it is harmonic. So you have u x y, write it again, exponent of 4x cosine of 4y minus 6x plus 2y plus 3. So for this to be harmonic, from what you have just checked in the previous question, is that when you check the second derivative of the function with respect to x and with respect to y, the answer should give you 0 when you add the two of them. So now we get du dx, first derivative. So differentiate with respect to x. So this variable is this function is the one that has an x. So you drop what? Drop 4. You remain with exponent of 4x cosine of 4y. Remember, you don't tamper with the function that has a y. Are we together? The part that has a y, it remains as a constant. Then we have minus what? Minus 6. There is no x. There is no x. So you don't differentiate. Twice u dx squared. So again, drop 4 gives you what? 16 exponent 4x, then gives you cosine of 4y. There's no x here, so you don't differentiate that. Now let's come to the second part. Okay, with respect to now y, du dy. So when you differentiate cos, you get negative sign, so it gets negative. Then there's a constant here which is 4, so you bring it outside. So you have 4 exponent, 4x remains because it is a constant. Then this one changes to become what? It becomes sine 4y. There's no y here, so differentiate this, you get plus what? Plus 2. There's no y here, so it is a constant, we don't differentiate it. So d squared u with respect to y squared the second time. When you differentiate sine, you get cos. Are you together? So this negative remains. Alright? So because when you differentiate sine, it gives you positive of cos. Then there's a constant again 4. Remove the 4 again. So 4 times negative 4 gives you negative 16. Are you together? Then exponent of 4x. Then this one changes to become what? Cosine of 4y. There's no we don't have a what? We don't have a y here, so you don't differentiate. Then when you subtract these two, or when you add 16 exponent 4x cos 4y negative 16 4x cos 4y, what do you get? You'll get your answer to be 0, because one is a negative of the one is always a negative of the other, and so when you add them, basically it gives you 0. So we have proven the first one, that this one is what? It is harmonic. Are we together? So we just say u x y is harmonic. It is harmonic. Now whatever we have here, especially the first derivative, are going to help us in working the second part. The second part is asking that you determine the other part of the function. Remember, function has a real part and an imaginary part. Are we together? So you have been given the real part, which is u. Now you determine the other part, which is the imaginary part, that makes the whole function to be what? To be analytic. All right? Now, for functions to be analytic, two conditions have to be met. Derivative with respect to x should be the same as derivative dv dy. Right, together, that's the first part. The second one is dv dx should be the same as negative du dy. So these two conditions have to be met. All right. Now, so we shall use these two conditions to get our other function of v. Now, let's start with the first one. Du dx should be the same as dv dy. Okay, du dx should be the same as dv dy. Now, let's come to our derivatives. What do we have as our du dx? Our du dx is given by that. Are you together? So therefore, what is my dv dy? What is my dv dy? This should be the same as that. So therefore, my dv dy will be given by the same function because they are the same. So it is 4 exponent 4x cosine 4y then minus 6. Are you together? They are the same. So therefore, if this one is my du dx, therefore also it should also be my dv dy. Now this one is a derivative. All right. So we want to go back to v. Remember, our intention is to find our function of v. Now, you have a function which has already been differentiated. How do you go back to v? You integrate. So for us to get v, integrate this side and you get your v. But now here we shall get it with respect to y, because you're integrating it with respect to y. Why? Because our function was differentiated with respect to y. Are you together? Yes. So we have that. So now for us to get v, integrate this function. So integrating that part. So remember, we're integrating with respect to y. So you're integrating only the y part. Are you together? So what is the rule of integration? You divide by the constant. So when you integrate cos, you get positive sign. Are you together? So we shall have 4 exponent of 4x. This one becomes sine of 4y, but you divide by the constant. What is our constant? Our constant is 4. Then minus the power of y here was 0. So we always say just introduce the variable y, because you are always increasing the power dividing by the new power. So our power here was y to power 0, because anything to power 0 is 1. So you increase it by 1. So 0 plus 1 gives you 1. So, but what we always say is just input the variable of integration. Then plus we shall put a constant. Let me write it in terms of c. A c, then we shall put it in terms of x. Remember, our v should be a function of x and y. So since we have variables in terms of x, so introduce in terms of y, we introduce that in terms of we assume it was in terms of x. It was a constant, but now it had an x. The same way you always put a constant when you're doing integration. It's the same thing we're doing here, but now we put it as a variable of x. Now the 4 and the 4 cancels. You remain with exponent 4x sine 4y minus 6y plus a constant of integration. Now that will be a v with respect to y. Now this part leads us here. Are we together? The first part leads us here. Now we come to the second part, this part. So this part will lead us to now getting our v in terms of x and y. Now we have our v function here. I want us to get now dv we differentiate with respect to x because we don't have it. Do we have dv dx? No, there's no dv dx, but we have du dy. Are you together? So now differentiate this with respect to x. So therefore your dv with respect to x, now differentiate this function with respect to x. So this part is the only part that has an x, so that one will be 4 exponent 4x, then you get what? Sine of 4y. Do we have an x here? No. Right, together. So you don't differentiate that part. It must have an x. So don't differentiate that, but you differentiate this part because you have said we take it as a variable of x. So plus, now we shall put it as c prime x. Why prime x? To show that this has been differentiated. But we don't know the function that is supposed to be here. So that is why we are just putting c prime x. The prime is just a derivative, so we have this. Then now this part, since we have dv dx, we now come and compare the last part. The last part says that your dv dx should be the same as negative du dy. Now what is our dv dx? We have 4 exponent 4x, then sine of 4y, then plus a constant of integration. Well, not a constant, a derivative. This is a derivative. Should be the same as negative of du dy. So we come back and check where is our du dy. Du dy, here it is. So it is given by negative 4 exponent 4x sine 4y into bracket. Okay, we have that, sorry. Then we have plus 2. Plus 2. Are you together? So again, we're just saying 4 exponent 4x sine 4y plus x is given you negative negative positive. So 4 exponent 4x sine of 4y negative positive negative negative 2. So if you check these two functions, they are one and the same thing because this part is the same as that part. So if that is the case, if our first part is the same as the first part, therefore the second part should also be the same as the second part. So we shall have c prime x will give us what? Will give us negative 2. But remember, our c prime x is a derivative. So how do we get cx? So this part is the one enabling us to get this constant here, so that we can now have the actual function that you're supposed to have, this function, because we have a missing part which we don't know the function. So now, so we have this, it's a derivative. So for us to get cx, you integrate this side and this side with respect to what? With respect to x. This one is a derivative. So for us to go back to the actual function, then you integrate. So therefore, when you integrate negative 2, you introduce the variable x. So it is negative 2 what? Negative 2x. In this place, you don't introduce another constant. So your constant, therefore, cx is given by negative 2x. So therefore, now, your function of x with respect now to x and what? And y will be given by this function. So it is exponent 4x sine 4y minus 6y. Then our constant is what? Negative 2x. And that is the function that makes f of z incomplete to be what? To be analytic. And these are the same steps you will follow again and again when you're determining another conjugate function that makes the function to be analytic. So use the two conditions that you have been given to get what you need. So use the first one, compare this and this, so you'll have dv dy, then integrate for you to get v. Then the function of v, differentiate it for you to get dv dx. Then compare dv dx with what you have as du dy, negative of du dy. And from that point, you get your prime of x, then integrate that. Integrate it, you now replace your constant in the function that you have. So thank you and see you in the next lesson.